Hello guys, welcome back to my channel Code with Med. So today we are going to start with a new topic, system call. In this topic, we are going to see some examples of system call, right? And let's start. So what is system call? System call is a special kind of procedure call where the user programs need something work to be done by the operating system, right? So there is a change in the mode from user mode to kernel mode, and operating system performs the work and give back the result to the user, and then continues its operation. As you already know, in a single core system, at one time only one process can execute, right? So if a process demands a system call, right? Then it needs to wait so that the operating system performs the work need to be done by the system need, that is indicated by the system call, and it returns, and then it performs continuing the execution, right? So we now know what is system call. Okay, let me tell you that system call is a slightly different from procedure call in such a way that in procedure call what happens is that in procedure call what happens is that it doesn't changes from user mode to kernel mode, but a system call is a special kind of procedure call, so it changes from user mode to it changes the mode from user mode to kernel mode, right? Also, when the in procedure call, when the control transfers uh, to another location, so this location is arbitrary, but in case of system call, the the control transfer to another location, and this is not arbitrary because this is in kernel space, right? Let us suppose system call there is a system call, a process is executing, and it demands a system call read, right? So what happens? Let me show you with the help of diagram that what happens in this case. So read will be having three parameters: file that it is pointing to, that it need to be readed, buffer, and the bytes that it needs to read from the file, right? So these arguments are firstly stored in the stack, right? These arguments are firstly stored in the stack, and then what happens? It generates a trap which will be handled by the operating system, and where the trap is stored, it needs to be stored at a particular place where operating system gets to know that if there is something in this register, which this means a trap is generated, and the control needs to be transferred from user mode to kernel mode, right? So this space is like something like register, right? So uh, a trap is generated, then the code for that trap, uh, every system call has some code associated with it. So the code is written in the register. Operating system reads it. Operating system reads this trap, and the control transfer to appropriate system call handler which is associated to this particular trap code, right? And how this happens? Operating system maintains a table which determines the system call handler for each and every trap code, right? Here you can see, and the system call handler then executes whatever the system call wants, and then gives back it to the place from where the system call is generated, and performs continuing its work, and then the whole stack is then removed, whole stack is then cleared, right? So that the upcoming work needs to be done. Okay, yeah. Hmm. Sorry. So now let us consider about another system call which is very important, that is fork. Okay, what happens? Fork, as I've already told you in my previous videos. So what fork does, if a process is executing and a fork system call is generated, this means a fork system call is generated, then this means uh, there is need to create another child process which is very similar, which is very similar to this parent process, right? Which is very similar to this parent process. Each and every value of temporary variables and each and everything will be same. Each and every status will be same, which means that both will be start in the running mode. If this is in running mode, both will be started in the running mode, right? Now, as both are copy of each other, just after the fork system call, right? But as soon as the fork system call is successfully generated, then both will work independently of each other, right? But now, as both are copy of each other, then how will control move back to the parent process? It needs to know na, that which process it was executing. How will it come to know? It comes to know with the help of the return value of the fork. The fork returns the value of the PID of this process, child process, PID of child process, the parent process. But the fork returned 0 to the child process only, right? The fork returns PID of the child process to the parent process, right? To the parent process, PID of the child process is returned, but to the child process, 0 is returned, which helps to determine that which one is the parent process and which one is the child process, right? Yeah. Now, let us suppose let us suppose that the child process is executing, right? The child process. Uh, Now, let us suppose that the child process is executing, and the parent process is also there. So the control will move back to the parent process. So it needs to tell that if it needs to tell that let the child process terminate, continue its work, then which system call will be needed? The system call will be wait PID. Wait PID. It tells the parent process to let the child process continue its work and terminate, and then continue your own work, right? We can also pass the value of another child process of this parent process rather than just this one. Okay, so we can pass the argument here so that it will wait for the termination of this particular child process, right? And now let us suppose this child process is executing. Then a system call execve is given. This child process gets a system call of execve, which means gives the system call of execve, which means all the commands that will be written on the terminal will be handled by the child process itself. Okay, all the commands will be written in the terminal will be handled by the child process itself. Okay, which means let us suppose uh, cat the command will be written that is written on the terminal processes uh, cat or leave it cp file 1 and file 2, right? So this is the command. So what happens is that this will be handled by the child process itself. So how it will be handled, like this, how it will be handled, this will be executed in the form of a function like this: main argv, argc, then argv, then envp file 2. This is cut. Okay, so file 2 argv, envp. So what is ARGC, ARGV, and ENVP? ARGC means the count of the arguments. Here, the count of argument is 3, right? CP, first is CP, second is file 1, third is file 2, right? Here the count of IRGC value is 3. What is ARGV? ARGV is the pointer to the array, which which is pointing to CP, file 1 and file 2, which is pointing to the argument itself. Okay, so ARGV 0, ARGV 0 means is pointing to CP. ARGV 1 is pointing to file 1, file 1. ARGV 2 is pointing to file 2, right? File 2. So an ENVP is giving the environment that is set before executing this this command, right? We set some variables, we set something that is before executing something. So this is that like it is pointing to that array. ENVP pointing to that array, which is helpful in setting the environment, right? So thank you for watching this video patiently, patience, patiently, right? So please hit the like button, subscribe, and comment if you're having any doubt. Thank you so much. We will come like unit 1 is completed, right? We will move forward to unit 2. There are 4 units. So let's meet again. Bye. Thank you.